There we go. All right. All right. Here we go with Advent of Code 2024, day 13. And this one is called Claw Contraption. Next up, the lobby of a resort on a tropical island. Oh, yeah, right, because we're traveling around to historical eras. 2020, day 24, eras. Not errors, eras. The historians take a moment to admire the hexagonal floor tiles before spreading out. Fortunately, it looks like the resort has a new arcade. Just a link to arcade, amusement arcade. Maybe you can win some prizes from claw machines. The claw machines here are a little unusual. Instead of a joystick or directional buttons to control the claw, these machines have two buttons labeled A and B. Worse, you can't just put in a token and play. It costs 3 tokens to push the A button and 1 token to push the B button. With little experimentation, you figure out that each machine's buttons are configured to move the claw a specific amount to the right along the x-axis and a specific amount forward along the y-axis each time that button is pressed. All right, so we have button A. I'm looking at the text here. It looks like A plus 94, Y plus 34. Okay. And it costs 3 for A and 1 for B. Each machine contains 1 prize. To win the prize, the claw must be positioned exactly above the prize on both the X and Y axis. Okay, so we just need to push A. What is the smallest number of tokens you have to spend to win as many prizes as possible? You assemble a list of every machine's button behavior and prize location. Right, so we just push A and push B until we get over X, Y. We can't go backwards. We can only go forwards. Okay. It feels like the coin problem, where you calculate how many coins it takes to make a certain amount of money, which I've done before. I did that in LeetCode. Where's my? I don't have my. Oops, I got I got capitalize. That? No. What did I call it then? Oh, I'm gone? Oh, I typoed my own name. Okay. Well, my handle. All right. Right. The coined thing is coin change. Yeah. And I did a recursive solution, and then I did an iterative solution. I remember doing that. This isn't exactly the same because we have 2 dimensions to deal with, X and Y. All right. Well, let me think while we get the input. 2024, day 13. 1279 lines. Wow. Is it always plus? Let's see grep for O. X minus or dot minus in that file. There's no minus signs. So that makes parsing easy. It's always going to be X plus something or Y plus something. So we just go for that. All right. Let's see if we can do this. Let's create a struct claw. And it's going to have an A button, button A. Let's do everything like this for now, and then we can change it if we need to. And then the prize is going to be I64, I64. And then we'll impl from stir for claw. Pull in that import, create the missing member. We're not going to have any errors. Oh, right. Okay, yes. I do have a read records. Let data equals AOC lib read. Oh, I have read num records. I don't have just read text records. Well, let's write one. That's the easiest way to get things done, right? Is to actually write them. Generate a read text records function. Is this in the right spot? I guess it is. I should probably put all of these in readers. Yeah, so basically we just split on a double new line. And we're going to do the same thing here with P and as, oh, I called it T up there. I want to start naming my single letter types with the name of, with something significant. And this is going to return a vec of strings. No, it's going to return a vec of string that we can split. Yeah, let's do this. That way we can split each line up. So it's basically read to string, path name, expect, unable to open file. And then we'll say split on double new line. And then each one of those gets split again. Right, let's filter record, not record is empty. No, I guess I can't do that. I was trying completion. It wasn't letting me complete. And then we'll map each one of those records into record split new line collect vec string. And then this can be collect into vec of string. Oh, I forgot to, that's why it wasn't working. Okay, that's better. What's missing here? Oh, I forgot these. Oh, I called it path. Okay. And what's the problem here? Oh, these are stirs. Okay. Can we say map s to string? I guess maybe keeping them as stirs makes sense. No, it doesn't, because this is going to disappear. After we do a read to string, we need to copy them out. Okay. So now we should have the records. Let's print out the first record just to see what we've got. Like this, data 0. Yeah, so we have button A, button B, and the prize. And then the last one, data len -1. And then we can look at the input. Oops. Is that the right thing? Oh, we got an extra blank line here at the end. Did I have that on the other one as well? I missed that. No, this one doesn't have the extra blank line. Oh, I know why. It's because of the... You know what? I'm not going to worry, because it's just this. So we'll do a vec clause. There's a vec of claw. And then we're going to do this. Self clause is equal to data iter map claw parse unwrap collect. And then I should be able to print out the first and last claw, and they should look good. Let's find out. Clause 0, and then clause self clause len -1. Keep forgetting that. No method name parse. This is from string, not from, oh, blah, 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 blah. Okay. Let's change read text records then, so we don't do this. So it's just a vec of string. And that way we can convert it from a string directly. Oops. I still have to string it. Claw doesn't implement debug. Okay, I can fix that. And we have a panic not yet implemented. Right, okay, so now what we're gonna do, here's where we'll split the string up. Let lines equals s split. Let's call it claw data. Split on a new line, collect. And this should be, oh, it says string like that. I wonder if this will work. Yeah, okay, it still works. And now we have 3 lines. We have the button A, button B, and the prize. So I can say let nothing that we care about, and then the XY value is equal to line 0. I think I can commonalize this, make a single function that does this, but we'll see. Line 0 split once on colon space unwrap. And this then is should be the X plus something comma Y plus something. And then we can split on XY on comma space unwrap. And now X should be X plus something and Y should be Y plus something. And we can parse that. Let X, Y equals X dot, no, X of 2 dot dot parse. What are we gonna use for all these usizes? Unwrap, and then Y2 dot dot parse usize unwrap. So these should now be usizes. Let me put a default here because I want to see if this will work. Default, and then I just say okay, self default, just to do something. I just want to print this out. X equals X, Y equals Y. How many are there of these? Nope. Input 2024-13.text. 320. Okay, so that won't be too bad. We'll see 320 of these guys. Put this in the clip buffer. Okay, so at the top we have 4224, then 8934, then 8518. Okay, good enough. So we can make this a common thing and have it give us the data we're looking for. Fn get xy from a string. Usize. So we just do that. And that gives us our XY values for each line. So let button A. Oh, I put I64s in here. Let me make these I64s. So button A is equal to get XY of line 0. Probably have to put an ampersand in front of it. Button B, lines 1. And let prize is equal to get XY lines 2. Yeah, so we do this, we don't care about that extra blank in there. And then we can just say self button A, button B, and prize. All right. Oh, and this printed out the first one and the last one. So the first one is 4224, 2355, and yes? And then the last one is this and this and that. Okay, I think we got it. Now we just need to calculate the thing and sum them up. So part one, it will be, we probably could just write it all in one go, right? We can say self clause, iter, map claw, calc tokens, right? It's just summing up. What's the fewest tokens you would have to spend to win all possible prizes? Yeah, so we just sum up all of those. So we have a test. We know the first one is 280. The second one, oh, second and fourth don't have it. We have to make sure we can, okay. And then the third one has 200. All right. So we can write those as tests. But this is what this will be, calc tokens. Oh, we can just probably, oops. Can I do this? Claw, calc tokens, and then sum, I64. Since it looks like we're doing everything in I64. I'll change it to usize if we need to. Extract into variable. Okay, let's say impl claw fn calc tokens. Oh, yeah, we'll have to do a filter map because some of them might not work, right? That's what I read just now. So this will be self, and it'll be an option of I64. Right now, I'll just do sum 1. And since there's 320, we should get 320 as a result. We do. Look at that, 320. Okay, I think we're set up now to actually write the code. Oh, let's get rid of these two lines. Yeah. Okay, I think we're set up now to write the code. Let's commit this because this seems like the framework we want to use. Git status. Git. Ooh, right. Let's add this separately. Git commit. Read records separated by 2 new lines. Okay, git add source, git status, that's just these guys, git commit -m 2024 day 13, parsing, and framework. Okay, I think we're at a good spot now where we can try to figure out what's going on here. The first thing, so if we look at the coin thing, right? It's basically you subtract one and then you subtract the other, and you can either, like I was showing before, do it recursively. This is the recursive solution. Or you could do it with an iterative approach if you create a vector of all of your values. We can try it this way and see how far we get. I'm a little nervous about it because there's 320 we have to go through, and the numbers are pretty big, right? We're looking at numbers that are in the, and to get, to 93 from there is going to take a bunch. What did they say for this one? Where was it? Yeah, we have to push the A button 80 times and the B button 40 times. Yikes. All right, well, we're going to try it this way, and then we'll see. Maybe there's a better approach. And we need to keep track of how many times we push the A button and the B button. So let's say fn calc recursive. And this will just be an associated function. We're not going to pass in self because I want to subtract off from prize. We're going to have how many A tokens? Toke A, which is going to be usize, and toke, I64. Toke B, I64. the current A value, the current A button, and the current B button, and the remaining prize location to get to prize. I-64, I-64, and this will return an option I-64 with lowercase I. Okay, wow, that's a lot of things. And then this will just call that. So this will be self calc recursive 0 tokens, 0 tokens, self button A, and self button B, and then the prize. And yeah, and we're going to make this mutable. Mutable. Okay, so we can see if so this one's 280, this one's 200. We add them together to get 480. You estimate that each button would need to be pressed no more than 100 times. Okay, so that helps narrow it down, I guess. If toke A is greater than 100 or toke B is greater than 100, we can return none. And then we can say if prize is equal to 0, 0, return sum 3 times token A plus B. Right? I said three tokens for A and 1 token for B. Okay. Otherwise, if prize 0 is greater than A0 and prize 1 is greater than A1, then we can push the A button. So this will be calc recursive of token A plus 1 and token B, AB, and then prize 0 minus A0, greater than or equal to prize 1 minus A1. Else let solution A, else none. Right, and then we do the same thing for B. B. Nope. This token A and then token B plus 1. And then minus B1. Okay, and now this will be either some or none. And we want to return the minimum of the two of those, right? So solution A, solution B, filter map X, I guess, min. Will that do the trick? Oh, prize equals, yes. I can't use calc recursive. Oh, self. I can't filter map. I have to iter on that first. And then I have to deref for that. It's saying to put it and wrap it in a sum, but I need to deref it because this will be a sum or a none. And we have abject failure. It's computing. That means that we have an infinite loop. Let's instead of doing all of them, let's just do one of them. AOC lib output unsolved. Let's just do the first. Oh, let's do a test. Let's write the test here. Oops. Test. Part 1. Example 1. Sure. And that was this guy here. So we could just create the claw directly. Let claw equals claw button A. is 94. 34. Oops. Button B is 2267, and the prize is at 84005400. Right? And we're going to say assert EQ sum 280 claw calculate tokens. Oop. Yeah, we don't pass anything in. Okay. Oops, I keep putting that there. Okay. So let's run cargo test part 1. I think I can say AOC 2024-13, and it'll just test that one. Yeah. Oh, I don't need to mutate that. It's true. Okay, so let's print out what we're getting. Maybe we can do that. Are we getting a solution? Println took A, took B. Are we getting any solutions? Oh, right. This is a test, so we're not going to. That sucks. Okay, forget the test. We're going to just do one directly in part 1. Oops. Oh, did I forget a semi? I did. Okay. All right. So cargo run less. Oops. Cargo run less. We are seeing 80-40. So it's finding it right away. Why isn't it stopping? Why is it still going? If we found, I must have. My brain sometimes just doesn't get things. Yeah, so this is the loop here, right? And then we just return min coins. Why is it still looking after we found an answer? Is it because we're going into B here? Probably. If solution A is none, else what did I do wrong here? We don't want the none there. Oh yeah, no, we do. None, semicolon, and then like this, and then we return that. Oh, I miss. Oh, that's what I did wrong. I put a close instead of an open. Okay. Is that any better? Yeah, okay. So now it finds it right away. Okay. So we should be able to run through all of the solutions now. Let's get rid of this. And get rid of those guys. Get rid of the print, otherwise it's going to blast us with printed statements there. Cargo run. I'm just going to do this in case it's infinite. It's still very slow. Let's do this. Let's print out each one as we try to calculate it. See how slow it actually is. If solution A is none, you don't need the filter map. You're right. That was left over. So I can just return this. Instead of doing that, shouldn't you have it else if? Maybe. Let me see if I can get it working first before I. Oh wow. So it's slow. So the test went quickly, right? We might have to come up with a different approach. Yeah, so the test goes fast. This is slow for some reason. And it's not like it's that much bigger. I guess it is. guess 94 is big enough that we get there eventually. Or maybe that's a none, and that's why, so now it's searching everything to try to find a solution. All right, we can't use this approach. Dang it. So this will work great if it could actually find a solution, but if it can't find a solution, then it takes forever to figure out it can't. That's a shame. Let's see if we can watch it as it's going to see if this is really the case. A, B, prize. I just want to watch things just to see what's going on here, and then less. All right. So it is slowly going down. But this is not going to converge anytime soon. Okay. So we need a different approach. Let's throw this out. Calc recursive is no good. And let's think about what we want, actually, instead of just trying to follow the coin problem slavishly. Scoop says you can loop from 0 to 100 and figure out the leftover from the moves and decide if B is a whole divider of that remainder. You might be able to just calculate it directly. Let me work out the maths here. We have more than one math going on. We know that the prize of X is going to be equal to A's X times some number of button pushes. I'll call it M. Plus B's X times some number of button pushes, N. Where M is equal to number of times A is pushed, and N is equal to number of times B is pushed. All right, and then PY is going to be equal to AY times M plus BY times N. Well, let's rearrange for M. M is going to be equal to, let's say, PX minus BX times N divided by AX. It's also going to be equal to, if we do the other equation, PY minus BY times N, divided by AY. So these two equations are equal, right? We should be able to write this. PX minus BX times N is divided by AX is equal to PY minus BY times N divided by AY. And now we can multiply both sides by AY. So we'll have AY divided by AX times PX minus BX times N is equal to PY minus BY times N. Is that true? That means that we can do that. And then we can say BY times N is equal to PY minus this thing. Does that even help? And then N is equal to this whole thing divided by, I think I must have done something wrong. This doesn't look right. I'm trying to get N on one side so I can just calculate N. We should be able to reduce this because all of these values are known quantities except for N. So I should be able to rearrange this such that N is on one side, and then I can calculate N, and then I can substitute back into one of these two equations to calculate M. And M is just, it's M times 3 plus N for the answer. Where am I going wrong? I'm used to writing out equations, so putting it in a comment is making me struggle here. Yeah, because unfortunately this N is, there's an N still here on this side of the equation. maybe this is not a good step to do. Maybe I need to do a different step. Maybe what I can do, let's write it this way. And maybe it'd be easier for me to visualize. I'm more of a visual person, right? This is equal to this over AY. So we can separate this into, oops. We can separate this into PX divided by AX minus BX times N divided by AX. Or would it be simpler to just cross multiply these things? Yeah, if we just do the cross multiply, that should work, right? If we say AY times PX minus BX times N is equal to AX times PX minus BY times N. Yeah, I think this'll be easier. And we can now distribute AY times PX minus AY times BX times N is equal to AX times PX minus AX times BY times N. Right, and then now we can move the terms, the N terms on one side. Right, if we add this bit, this bit here on both sides and then subtract that, so we should be able to say AX times PY times N minus AY times BX times N is equal to AX times PX minus AY times PX. Interesting. Did I get that right? AX times PX, yeah. This is AY. Oh no. I'm glad I double checked. This should be AY on this side. Yes, Ice Cold Witch, thank you. You spotted it as well. This should be PY. Yeah, it seemed wrong multiplying by PX both times, right? All right, what else did I mess up? PY minus BY, blah, blah, blah. Okay, good. And now we can strip out the N, right? We can say N times AX times PY minus AY times BX. Did I get this right too? AY times PX, AY times BX. Yeah, I messed that up. Wow. Lots of opportunities to make mistakes, right? And then it's AY times BX times N. That looks right. The line above that. Did I get this line wrong? PX minus BX times N over AX and PY minus BY times N over AY. Yeah, that looks right. So here, we multiply AY here, and we get AY times PX BX minus N, AX PY minus BY times N. This looks right. And now I distributed the AY times PX, AY times BX times N, AX times PY, AX times PY. Oh, there it is. There it is. BY times N. Okay. Okay, so now let's double check this line here. We have to move AX BY N over here. And this stays the same, AY BX N. Aren't you glad you turned into a Rust programming stream, everyone? AX times PY minus AY times PX. Okay, so I think we're almost there. So we combine the combine this. It's AY times BX, yes, is equal to this guy here. So now we divide. N, let's go one more down. N is equal to this guy over this guy. Okay, so we've calculated n. And that means we can get m from either one of these equations. Doesn't matter which. They should both work. Okay, so calc. So we can actually just modify calc tokens to do it directly. Instead of calling calc recursive, let's calculate n. N is, I called everything x and y, and this is 0 and 1. So I'm gonna, here's another opportunity to make mistakes. So we're gonna say let n is equal to button A 0 times prize 1 minus button A1 times prize 0, and all of this divided by, couldn't you factor out AX and AY? Oh yeah, probably. I actually I don't know. But we're doing it this way. And it's divided by button A0 times button B1 minus button A1 times button B0. So that's n. So this is n, the number of times the button B is pushed. M is going to be this solution here. So it's going to be prize 0 minus button B0 times n divided by button A0. I just use this first line here. But now we have to see, actually, because we're doing a bunch of division, we got to make sure that actually adds up. So if button A dot 0 times m plus button A dot 1 times n, comma, button, no, I got that wrong. Button B dot 0 times m, n, comma, A times m and B1 times n is equal to prize. Then return some 3 times m plus n. Else, none. And everything blew up. Oh, I have to put self in front of everything here. Misery says for M, just swap A and B. Oh, okay. Yeah, you could do that. This should be a plus here. Does that build? Oh, yes. So let's just put underscores here just to leave our bad solution in place. Cargo run. We got a number. 37680. Didn't panic. It didn't crash. Didn't blow up out of memory. Hey, that's the right answer. Okay. So I can math. That's the good news. Let's move this comment into this function, or above this function, so we can describe what we're doing. Let's just change this. Yeah, this looks good. Just make button equals self button. Yeah, I should have done that, right? Okay. That works. I'm not thrilled the way the code looks. This kind of looks ugly, but what are you gonna do? I could do like what Halloween was suggesting. Let me change that. Let A equals button A. Let B equals button B. Let prize equal self. Let's see, I forgot the self again. Self fries. And now I can change all of these, and maybe it'll all jump up into one line. We can hope. Self fries, self this. Oops. Like that. I forgot the semicolon. Hey, okay, that looks better. It's still not that legible, but it's mostly legible. Let's make sure I didn't break it. I broke it. Where did I break it? This line looks right. Oh, wait, I broke this here. It's A0 times prize 1 plus. There. Okay. Nope. All right, prize 1. A1 times prize 0. A0 times B1. A1 times B0. And then here, M is equal to prize 0 minus B0 times N divided by A0. Oh. Plus A1. Oh, plus. I got plus there. That's why. Minus. Yeah. Thanks, Halloween. Okay, got it. All right, so that's good. Git commit -am 2024 day 13 part 1. All right, let's see what part 2 is. Continue to part 2. As you go to win the first prize, you discover that the claw is nowhere near where you expect it to be due to unit conversion error in your measurements. The position of every prize is actually whatever this number is higher on both the X and Y axes. Now it's only possible to win a prize on the second and fourth claw machines. Unfortunately, it would take many more than 100 presses to do so. Using the corrected prize coordinates. Oh yeah, I didn't even check to see. That would have been clever if he had some that didn't. Okay, anyway. What's the fuse tokens? Okay, so I think with the new way we did things, it shouldn't be that hard to change. Rename recursive? I'm leaving it. Maybe I should just blow it away at this point, right? It was part of figuring out that we couldn't do it as part of part 1. So let's just delete it for part 2. Calc tokens now, I guess, will take a parameter, which means we can't do this code here unless we just call it calc var tokens or something. We can do that. Scaled. Let's do that. And then we can just here with scale scale I64, and so now our prize is different. It's going to be self prize plus scale prize 0 and self prize 1 plus scale, and hopefully it doesn't blow up the I64s. And now fn calc tokens self is just going to return an option of I64 and call calc tokens with scale 0, and then calc scaled is calc tokens with scale whatever that number is. $10 trillion. Did I miss a self somewhere? Oh, self dot. You're right. Thanks, Scoops. He was looking out for me. There we go. Ginormous number. That's right. I would have been surprised if it was wrong because I would have expected Rust to blow up if the numbers got too big instead of coming up with a completely wrong answer.